I argue that black holes located at the center of galaxies do not possess their own mass. Instead, their mass is a collective sum of the surrounding stars, representing the combined gravitational force exerted by these stars at that specific point. To comprehend this concept, we can consider how the gravitational force of objects, such as Earth, is calculated. The mass is treated as if it were concentrated at the center. As a result, each point on Earth's surface experiences a different gravitational force based on its distance from the center. For example, the gravitational pull is weaker near the equator than at the poles due to the greater distance from Earth's center. However, no one suggests that the center of Earth actually contains the entirety of its mass. Instead, it is understood that the mass outside the center is responsible for Earth's gravity. Similar principles apply to galaxies. The gravity every star in the galaxy feels is the total gravity of stars in the radius to the center of the galaxy. If black holes possessed their own mass, they would eventually consume all matter, growing to immense sizes. I propose that the center of a galaxy is merely a virtual point where the surrounding mass is accounted for. As the matter is drawn towards this point, it becomes compressed by the collective gravitational force of the entire galaxy. Consequently, atoms are expelled back into space, akin to passing through a massive accelerator. These expulsions of matter, resulting from stars entering the center of mass of the entire galaxy, move in directions perpendicular to the swirling star disk surface. This phenomenon is observed in images from the Hubble Space Telescope, displaying two jets of matter emanating from the centers of galaxies. Hence, as matter is drawn into the event horizon of a black hole, the black hole itself does not increase in size. Rather, it maintains its original gravitational force, representing the total gravitational force of the entire galaxy. Black hole doesn't emit light since it has no mass and since it is only virtual point as the virtual center of gravity of the whole galaxy. Consider a scenario with two stars at a distance x from each other, each having the same mass m now. If one of the stars suddenly collapses into a black hole, as suggested by some scientists, and the distance between the black hole and the nearby star remains constant, and the mass of the black hole is equal to that of the original star, then the gravitational force experienced by the nearby star should not undergo significant changes. The gravitational force between two objects depends on their masses and the distance separating them. As long as the mass and distance factors remain constant, the influence of the collapsing star, black hole, on the nearby star should not experience substantial alterations.